Hey, very good morning, students. Let us look into our very next topic called Programmable Array Logic. So, this PAL is most commonly used PLD. You know, PLD is of two types, simple PLD and complex PLD. Simple PLD is of four types, PROM, PLA and PAL. Now, we are going to learn about this PAL. So, let us understand the difference between the first three, PROM, PLA and PAL. See, PROM is a circuit where you have fixed AND gates and programmable OR gates. Okay. Whereas PAL is a circuit where you have a programmable AND gate and fixed OR gate. Can you see? It is reversed to PROM. PROM has fixed AND, programmable OR, whereas PAL has programmable and fixed OR. PLA is a circuit which has both programmable and programmable OR. We have done with PROM in the previous video. We have seen about PLA in the previous video. Now we are going to see about PAL. The architecture of PAL is simple. It has inputs and outputs. Between inputs and outputs, there are two stages. One is programmable AND stage, other one is fixed OR stage. Now we are going to design this PAL circuit. Now see the question. The question is design a PAL circuit. So he has given the question here. So F2 and F1 are the two functions given and he wants us to design this F2 and F1. So if you see F2 and F1, question is design the given function F1 and F2 using PAL. That is the question. I repeat, the question is he has given two functions F1 and F2 and he wants us to design these two functions using PAL. So first step in designing this, you need to minimize the function. So I have taken the function F1 and I have taken the function F2. I try to minimize it. See, I have taken F2 here. What is common between the first two terms? A bar B is common. So I have brought this A bar B outside. So C bar plus C will be remaining here, followed by A plus B bar C plus A B C bar. So C plus C bar is 1. So F2 is A bar B, A B bar C and A B C bar. So let us reduce F1 also. F1 is a function which has three terms. Let us try to reduce it. If you see these three terms, the second term and third term, if you see this, it is A bar B, C bar D. If you see B, C bar D, B, C bar D. So these two are common. So if I take this B, C bar D common out, I get A bar plus A plus this A bar B, C, D bar. A bar plus A is 1. So I get B, C bar D plus A bar B, C, D bar. So instead of three terms, I have got two terms. So first step, I repeat, the question is design the given Boolean function F1 and F2 using PAL, or implement the given Boolean function F1 and F2 using PAL. For that, first take the function F1 and F2, try to minimize it. Okay, after minimizing, what you do is you need to draw the implementation circuit. In implementation circuit, you know that first you need to write number of inputs. Now see how many inputs are there? A, B, C and D. So the function F1 and F2 has four terms, four variables A, B, C, D. So I have taken four variables A, B, C, D. Now this is A variable, this is A bar variable, B, B bar, C, C bar, D, D bar. So I have taken all the inputs and stretched the line, right? Now instead of using this gate, I can use this also. Take single input A. The output can be A and A bar. If it comes from bubble, I call it as A bar. If it comes directly from here, I call it as A. Instead of having two symbols, I can have a single symbol and write one as A and other one as A bar. Okay. Either I can write like this, or I can draw like this, or I can draw like this. Okay. Now what is my next step? Now I need to know how many AND gates I need to give. So first step, number of inputs. Second step, number of AND terms. So number of AND terms is decided by number of minterms. In function f1 has 2 minterms. Function f2 has 3 minterms. Which function has more number of minterms? F2 has more number of minterms. How many? 3. So we need to fix that. For every function, there should be 3 minterms. Is it clear? So how will you identify number of AND gates? Number of AND gates is identified by number of minterms. In function f1 has 2 minterms. So f1 is equal to 2. For function f2 has 3 minterms, 1, 2, 3. f2 is equal to 3. So which function has greater minterms? f2 has greater minterms. So assign that to all. So whether f1 has 2 minterms also, you need to consider only 3. So now what I do? f1, function f1, though I have 2 minterms, how many AND gates I need to draw? 3 AND gates. f2 has 3 minterms, so 3 AND gates. Depending upon each function, you need to draw the AND gates. After drawing the AND gates, now what is the first gate? See, what is the first gate of F1? B, C bar, D. So go and draw a star mark in B, C bar and D. Will form what? B, C bar, D. What is the second term? A bar, B, C, D bar. So A bar, can you see? This is A bar, B, C, D bar connected. And do we have a third term? No. Why we have given this extra gate? Because as per the rule of PAL, number of minterms, what is the maximum number of minterms? 3. So since 3 is the maximum minterms, default you should have 3 gates, okay, for each function. Since there is no third term, I will not connect anything. It just goes as such. Now come to the next 3 gates. What is the first term? A bar B. So A bar cross mark, B cross mark. This is A bar B. Next is A B bar C. A B bar C. So A B bar C. Next is A B C bar. A B C bar. So connected. Okay. Now I have got all the AND terms. This is programmable. That is why we have given all cross mark. Now OR is fixed. What is OR? How many OR gates? F1 and F2. F1 and F2. You know what is F1? F1 is the addition of B C bar D plus A bar B C D bar. So B C bar D plus A bar B C D bar. Along with it, definitely we have to connect this third AND gate also. F2, you know F2 is combination of A bar B, A B bar C, A B C bar. So I put all this together and connect it to F2. So this is your fixed OR gate. This is your programmable AND gate. Number of AND gates is equal to maximum number of minterms in each function. So in this function 3 minterms. So we have to consider 3 as number of AND gates for every single function, whether it is F2 or F1. Maximum number of AND gates is 3, so I have to consider only 3. That is how we need to design what? A programmable logic, array logic, which has programmable AND gate, fixed OR gate. Thank you.